Hi students, welcome to the Math Online Tutor. This is the part 3 video of chapter 1 Relation and Function exercise 1.1, and this part I included 4 questions, question number 2 to 5, and last two part we discussed the first question and its sub question. If you directly come to this video first, please watch other two videos last posted. I put the links of those videos in description box. Okay, then we can start the second question. Show that the relation R in the set R of real numbers defined as R is equal to set of all A, B such that A less than or equal to B square is neither reflexive nor symmetry nor transitive. So the relation is what? A less than or equal to B square. So we can take that statement. So A less than or equal to B square. Okay, this number 1. So we have to show this. First R is what? Neither reflexive. Okay, then here we substitute what? B equal to A. Okay, then this becomes A less than or equal to A square. So this is true. This is true for all real numbers. For all real numbers, all real numbers, but except a positive real number less than 1. That means A lies between 0 and 1. It's not true. Okay. Suppose we take A equal to 0.5. Okay. What is A square? A square is equal to 0.5 square. That is equal to 5 square is equal to 25. So 0.5 square is equal to what? 0.25. So this means 0.5 not less than or equal to what? 0.25. This implies what? A not less than or equal to A square when A lies between 0 and 1. That means A is a positive real number less than 1. Okay. So therefore A comma A not belongs to R for all A belongs to R. This R is what? Set of all real numbers. Therefore R is not reflexive. R is not reflexive. Okay. Next we have to show that what? This not symmetric. Okay. So for that one, if take A comma B belongs to R, okay, this implies what? A less than or equal to B square. So you take to real number A equal to, first we can take A equal to 1, then B equal to 3. Okay, then first you can check this one. 1 less than or equal to 3 square. But 3 square is equal to what? 9. So this is true. Therefore 1 comma 3 belongs to R. Okay, then the reverse, but 3 not less than or equal to what? 1 square. Okay, this implies 3 comma 1 not belongs to R. That means what? B comma A not belongs to R for all A comma B belongs to our real number set. Therefore, R is not symmetric. Okay, symmetry relation. Next, you have to check what is not transitive. For that one, to take if A comma B belongs to R and B comma C belongs to R, this implies you can write A less than B square and B less than or equal to 6 square. So you take A equal to 6, okay, B equal to 3 and C equal to 2. First we check this one. So A equal to 6 less than or equal to 3 square. What is 3 square? 9. Okay, so 6 less than or equal to 9. And B 3 less than or equal to 2 square equal to 4. That means 3 less than or equal to 4. But 6 not less than or equal to what? 6 not less than or equal to what? 2 square. 2 square is equal to 4. This implies 6 comma 2 not belongs to R. That means A comma C not belongs to R for all real numbers, that is A, B, C belongs to R. R means set of all real number. Therefore, R is not transitive. Okay, R is not transitive. Okay. Third question, check whether the relation R defined in the set of all 1, 2, 3, 4, 5, 6 as relation R is equal to set of all A comma B such that B equal to A plus 1 is reflexive, symmetry or transitive. So you take this is our relation. Okay, this is our relation. So you write first B equal to A plus 1. Okay, number 1. Then this is our set. So you can write the set 1, 2, 3, 4, 5, 6. So the A and B takes the values of 1, 2, 3, 4 up to 6. Okay. So first you check this reflexive or not. Okay, reflexive or not. So for that one, first we defined the relation R. This is a set builder form. You can write in a tabular form. Okay. So first you take A equal to 1. What is B? B equal to what? A plus 1. That means what? 1 plus 1 equal to 2. This implies our point, the relation point 1, 2. Okay. Next, suppose A equal to 2, B is equal to what? 2 plus 1. That means 3. This implies 2, 3 is the point. Okay. Next, you take A equal to 3. B becomes what? 3 plus 1 equal to 4. This means our point is 3, 4. Okay. Next you take A equal to 4, then B becomes what? 4, 1, that is equal to 5, means what? 4, 5. Next A equal to what? 5, then B becomes what? 5 plus 1 equal to 6. The next point is what? 5, 6. Next, the last point, A equal to 6, B equal to what? 6 plus 1, that is 7. 7 not belongs to our set. Okay, not belongs to this set. So we can't take this point. Okay, that means 6, 7, we can't take, that not element of our relation. So R we can write, our relation R is equal to, write what? The set of all 1, 2, comma 2, 3, okay, comma 3, 4, then R 4, 5, next 5, 6. This is our relation. Okay, this is our relation. Then you check what? This relation is reflexive or not. For that, so you can take, yeah, listen, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 not belongs to this set. So 1, comma 1 not belongs to R, 2, comma 2 not belongs to R, etc. Last is 6, comma 6 not belongs to R. Therefore, R is not reflexive. Okay, reflexive relation. Next, you check what? Symmetric. The relation is symmetric or not. So you can take this 1, 2 belongs to R, but 2, 1 not belongs to R. Same like 2, 3 belongs to R, but 3, 2 not belongs to R. So here 1, 2 belongs to R, but 2, 1 not belongs to our relation. Therefore, R is not symmetric. Okay, R is not. Then third, you check what? This transitive. Transitive or not. For that, we can take 1, 2 and 2, 3. If 1, 2, 1, comma 2 belongs to R and 2, comma 3, 2, comma 3 belongs to R. Then you check 1, 3 belongs to R. You check here in 1, 3 belongs to R. No. But 1, 3 not belongs to R. Therefore, R is not R. Transitive. Transitive. Okay, not belong. Transitive. Hence, our relation is neither reflexive nor symmetric nor transitive. So question number 4. So that the relation R in R is a set of real numbers defined as R is equal to set of all A comma B such that A less than or equal to B is a reflexive and transitive but not symmetric. So our relation is A less than or equal to B. A and B are real numbers. So you take this statement. So A less than or equal to 1. Okay. First we show R is reflexive. So in this case, to substitute B equal to A in 1. So this comes A less than or equal to A. So A less than or equal to A implies either, here two condition, either A less than A or what, A equal to A. Okay, so here out of this, so here out of two conditions, okay, two conditions. So one condition, but one condition, A equal to A, true. Okay, therefore what, A less than or equal to A is true. Okay, this means A comma A belongs to what, R. For all A belongs to what, set of all real numbers. Okay, therefore R is reflexive, but reflexive relation. So for example, you take a 2 belongs to R, is a real number, then 2 less than or equal to 2 means here a 2 condition, either 2 equal to 2 or 2 less than 2. This 2 in 2 condition, one condition is satisfied, this means 2 less than or equal to 2, okay, satisfied, is true. Therefore 2 comma 2 belongs to what, our relation R. Okay, 2 is a real number, therefore R is reflexive. Next we have to show what is not symmetric. Okay, so for that, if you take A comma B belongs to R, then this implies what, A less than or equal to B. Okay, this implies B not less than or equal to A. Suppose you take A equal to 1, B equal to 2. So we can apply this one less than or equal to 2. One condition satisfied, less than condition satisfied. But 2 does not less than or equal to 1. Okay, this implies 2 comma 1 not belongs to R. This implies in general case B comma A not belongs to R for all A comma B belongs to set of all real number R. Therefore R is not symmetric. Okay, not symmetric. Next we have to show what, R is transitive. Okay, for that take, if A comma B belongs to R and B comma C belongs to R, this implies in first condition A less than or equal to B and B comma C belongs to R means B less than or equal to C. So here listen, A less than or equal to B and B less than or equal to C, therefore A less than or equal to C. This implies, okay, A less than or equal to, okay, this implies A comma C belongs to R for all A, B, C belongs to set of all real number. Okay, therefore R is transitive relation. Okay. For example, you can take A equal to 1, B equal to 2, and C equal to 3. Okay, so 1 2 belongs to R and 2 3 belongs to R. Okay, this implies R 1 less than or equal to 2 and 2 less than or equal to 3. 1 less than or equal to 2, 2 less than or equal to 3. Okay, this implies 1 less than or equal to 1 less than or equal to 3. This means 1 comma 3 belongs to R for all 1 2 3 are real numbers. That means R is what? Transitive. Okay. Fifth question, check whether the relation R in set of all real number defined by R equal to set of all a comma b such that a less than or equal to b cube is reflexive, symmetry or transitive. So this is a relation a less than or equal to a cube. Okay, so you take that one, a less than or equal to b cube 1. Okay, so first you check this reflexive or not. Okay, this given relation is reflexive or not. So here you put b equal to a. So this becomes what? A less than or equal to a cube. Okay, this is true for all real numbers. For all real numbers, okay, except the positive real number less than 1. That means the number lies between 0 and 1, other than this is true. Okay, if you take suppose take a equal to 0.5 less than positive real number less than 1. Okay, then a square, a cube equal to 0.5 cube. You know the 5 cube is equal to 125. That means 0.125. Okay, that means a 0.5 less than or equal to 0.125. No, not less than or equal to 0.125. This implies a not less than or equal to a cube. Okay, a cube. This means a comma a not belongs to R for all a belongs to R is set of all real numbers. Therefore, R not reflexive. Okay, reflexive. Okay, the next part, symmetric. Okay, check whether this relation R is symmetric or not. For that, take if a comma b belongs to R, then you check b comma c belongs to R or not. Okay, so a comma b belongs to R implies a less than or equal to p cube. Okay, then here we take a equal to what? 1, b equal to, okay, so here apply. So 1 less than or equal to 2 cube. What is 2 cube? 8. So 1 less than or equal to 8. Okay, correct. take the reverse part, but 2 not less than or equal to 1 cube. Okay, 1 cube means what? 1. So 2 less than, not less than or equal to 1. Okay, this implies what? 2 comma 1 not belongs to part R. Therefore, in general, this implies in general B comma A not belongs to part R for all A comma B belongs to R is set of all real numbers. Therefore, R is not part. Okay, R is not. Next, you check this part reflexive. Sorry, transitive. Third one is transitive. The relation is transitive or not. For this, take if A comma B belongs to R and B comma C belongs to R. So you have to check A comma C belongs to R or not. So this implies A comma B belongs to R means what? A less than or equal to B cube and B less than or equal to C cube. Then you check A less than or equal to C cube or not. So you take so you take A equal to 9 and B equal to 4, C equal to 2. Okay. So first this part 9 less than or equal to 4. What is 4 cube? C4. So A less than or equal to C. Correct. And so here B4 4 less than or equal to 2 cube. What is 2 cube? 2 cube is okay 4 less than or equal to 8. Then 9 less than or equal to check the 2 cube. 8. 9 less than or equal to 2 cube? No. 9 does not less than or equal to 8. This implies 9 comma 2 not belongs to R. This implies A comma C not belongs to R. Therefore, R is not transitive. Not transitive. Okay. So the question is, so R is neither reflexive nor symmetric nor transitive. Okay. So please click on subscribe button and bell icon to get the notification when upload the new videos. And if you like the video, please share your friends and relatives. Okay, thank you.